Um, okay, over to you, Sebastian.
Okay, thank you. All right, so afternoon. So today I thought I would cover three things. One is just to quickly introduce persistent object spawning. Another is local loopback, and then finally to go through an example of an answer for the exercise that we set when we introduced Ubiq. So let's get right in. I'll just share my screen here. And we'll start quickly talking about persistent objects. So this is a request that I understand was given during the Wednesday session last week. So just quickly show you, if anyone is interested, effectively how you would do persistent objects. So we've implemented this in version 003, which is on Moodle. It was put up this morning, if you'd all like to get a copy of that. And you might be familiar, if you remember this hierarchy, there is this network spawner component that is in the network scene. This is one of the services that we have implemented. And what I've done is I've added another static method called spawn persistent. So you'll remember that the fireworks box in the previous session just spawned a firework. Now I'm giving it the called spawn persistent. So this single component does both non-persistent and persistent spawning, and it does that by communicating that objects should spawn using two different methods. So the original way is still in there, so we still have the spawn, and what we do with that is we send a message over the network, and the remote instances of this network component will receive that message, get its parameters, so the index of the object to spawn and the shared ID that all of those instances should have, and will instantiate it. The other way to do that, the persistent way, is instead of sending a message directly, we send a message via a mechanism which has a persistent state. In this case, it is a property of the room. So the room object contains the peers, it contains a name, it has a unique identity, and it contains a dictionary, basically key value pairs, just a set of strings. And this instances of this room and this dictionary exist on the clients and on the server. So when you set one of these properties, that gets propagated to every client. And if you leave, that's persistent as long as the room is. So when somebody else joins, they get the room name, they get the list of peers, and they get that dictionary. So this method, it generates the new ID as normal. It even creates the exact same message that we send over the network. But instead of sending it directly, what we do is we write it into this little dictionary for the room, and that's it. So now that goes into the room, that automatically pushes that to the server, and then when the room dictionary changes, we get this callback that's issued whenever somebody changes a property of the room, say the name or changing the keys in the dictionary. And then when the room changes, this component iterates over all the keys, checks, is this key a spawned object message by just looking at the name, is it prefixed with spawned object? If so, it interprets the value of that key as our message and creates an instance of that object much the same as you would if it had received this message via the network, via the process message callback. And the difference in sending the message this way, again, is the room dictionary is persistent. So if I spawn an object and I leave, or I spawn an object and somebody joins later, they get the dictionary that has all those previous changes made to it. So they'll iterate through all the properties, and for everyone that matches, they will instantiate the object immediately. So that's one way to do spawned objects, and that's a pretty simple way. Other ways you could, if you had a pure peer-to-peer fashion, you could say, extend the number of messages that this object sends, and you could broadcast onto the network saying, give me the list of all the objects that you've all spawned. That would also work. This is just one way to do it, and it's a neat way to introduce you to the idea of this room dictionary. That's how you set it, and that's how you enumerate over it. Okay, so that's persistent objects. That's in 0.003. If there are any questions, please do go ahead and read the code, and if there are any questions, raise a ticket or put your virtual hand up in this chat. Right, so the next thing I wanted to talk about was local loopback. When you're developing, iteration time is very important. And when you're developing inter-process communication or netcode or anything that goes across memory spaces, development can be quite a pain because you need, for debugging purposes, to have two processes with the exact same code running, but for those processes to be completely separate so that you have a accurate view of how your code will behave in practice. That means creating two copies of the code on your disk. It means running two processes. It means running two debuggers, and it can be generally quite annoying. Ben has actually written a little script that copies the code for the Ubiq fork or project that you're going to create. And so you can run two copies of Unity perhaps without going through the entire source control and filling it up with loads of superfluous commits. But even then, when you're first starting out, even running two copies of Unity might not be ideal. So what we have also is this scene in the introduction folder called Hello World Local Loopback. This demonstrates how you can run effectively two peers within a single Unity scene. And the advantages of that is your code, both copies of your code, both instances of your objects that would be on two computers in reality now exist within the same process. So you only have one instance of the Unity editor. You only have to attach one debugger to see both your sending and receiving code working. They're in one memory space. And so, if you update a prefab, that gets updated to both all the game objects that reference it, even if those game objects in reality would be on two separate machines. Now, there are, of course, some pitfalls with this. You have to be quite disciplined because, while having direct references is good, for example, I have one prefab, say my fireworks box here. If I change this, it changes for every instance of this in both scenes. If I say a beginner and I made the mistake of creating a direct reference, say I had a property on Scene Manager on a new component and I dragged a game object from the second scene over into that, I've created a direct reference between these two instances of my social VR peer. That's going to work when I write it now, but when I actually put it on a real system and one of these goes away, there are no direct references across the processes, so that's going to fail. So it tricks me into thinking that my code is working when it isn't. And when I was first showing Ubiq to all the other, to everyone else, I made that mistake myself when I tried to write a nice fancy demonstration of the firework. And of course, my script changed some property based on a key input, ran it, it seemed to work wonderfully, and then Ben pointed out that of course it would, because both instances are checking for the same key on the same keyboard. So we didn't actually need the network to create that change. So let's talk a bit about how that actually works. The root of the network's existence, or what the network sees of the world, is this network scene component. This is the most important component in the scene as far as the networking goes. Now, if you remember from last week, my little introduction to the two layers, the messaging layer and the services, This message, the network scene, if you like, is almost like a manifestation in code of this messaging layer. So the network scene acts as the entry point for all of these and then sends all the messages across the network. So if you like, it's like the top level of the messaging layer. When I create an instance of a network component, when I do my registration, let's look at the firework example for this. So when I create my firework, when it comes into the world, when I spawned it, I register it with a network scene, which says it wants to send and receive messages to and from the network. What I'm actually doing is adding it or making an instance of this component aware of it. And I actually see that if I look at how this works, this method finds the network scene that this network component should attach to. And the way it finds it is it just searches a scene graph. So the first thing it does is it looks in its amongst its parents. So it looks for a direct ancestor which has this on it. If it doesn't find it, then it looks for the default scene. And the default scene is the one at the root of the scene graph. So you see this prefab here with this component on it doesn't have any parent. So when the game starts up, this network scene will consider itself the default, and anything which doesn't have a direct ancestor will find this one and consider it the network scene, which is fine for most cases. But what if this is not at the root of the scene? Or what if this doesn't have a direct parent? Well, in that case, it doesn't give up, it continues to search, and that functionality is what allows us to perform local loopback. If a network component doesn't have a direct ancestor, doesn't have the scene as a direct ancestor, and the scene doesn't have a default network scene component, so one of the root, it continues to search for the closest one in the scene graph. So that means the one with the fewest number of jumps that it takes to get from here to the existence of that component. So in this case, I start up the game. Neither of these are at the root because I've now put them under these game objects. These ones I'm calling forests. They're just the complete empty game objects, very simple, but what they do is they prevent either of these from considering itself as the default. So if I start up the firework, if I start up the game and the fireworks box comes to life, for example, it's going to need to find the scene via that method. So it's going to look up. It's not going to see the network scene in Forest 2. It's not going to see a default network scene because there is none. So then it's going to start searching downwards. So it's going to go to its first parent, and then it's going to look down in the hierarchy through here, until it comes to this one, and then it finds this and says, okay, that's my network scene. For this one, the avatar manager or the scene manager, they're going to look up, they're going to find it immediately, fine, they'll set themselves correctly. Same thing for this, but now if I have any component under this forest, it's going to find this network scene as its root. And what that allows me to do is effectively have one Unity scene with multiple network scene components in it. And as the network scene component kind of acts as the entry point to the messaging layer and turns these calls into messages that get sent out over the network, I effectively have multiple network clients all within one Unity scene and one Unity process. So that's how you would create one Unity scene. That's kind of the first half of this problem of local loopback. So now I can have multiple clients within one process. The next step is making them talk to each other, because now these have their own sets of connections. So I could, for example, have these talk directly to Nexus, and that would work. They would both be able to talk directly to Nexus because they operate from their point of view pretty much as a lone network scene would. But I can go one better. I can create myself a local server and have these connect to that. So this component, this room server, is kind of a very stripped down version of the server that's running on Nexus. And it serves mainly for development and debugging. So as an example, let's start up here. So in one way in which this is a little different, pardon me for leaving that over the main screen, if I come down here to network scene and, well, actually let me click in the main world, so I'm going to hit join. I've joined the room with this name here, this randomly generated GUID as the name. Now that wasn't the one I wanted to join. I wanted to join Hello World, but this room server doesn't care because it only has one room, and no matter what room you want to join, it's going to dump you in the same one because it's a stripped down version of the server, and its main job is to send and receive messages for you to debug your networking scripts. Now these are separate components, separate clients effectively, so I have to hit join on both of them, but you'll see the room server will put them all in the same room anyway. Now I've joined both of these clients to the same server, and you can see they're exchanging messages. And you can see here, if I look over, I will actually see a version of myself. So that's the remote version of this avatar I'm looking at right now, running just 14 meters away in the Unity world over a virtual network. And I can even, if I go to the forest, I can even rotate it. I kind of wave to myself. So that's local loopback. Now, the eagle-eyed amongst you might be wondering, okay, you saw my avatar over here, where is this one's avatar? Well, there's one other bit of asymmetry. This avatar manager for this scene's network scene instance doesn't have its prefab set. What that means is when this starts up, I will spawn a prefab in this version, which will connect to my VR player, or my desktop player in this case. This will spawn a counterpart to me, but I will not, there'll be no avatar for this side. So I won't spawn one, it won't spawn one. So this is kind of a dumb viewer of my world over here. But other than that, it works pretty much identically to the way it would over a real network. So we're going to use that now to see how we might implement a network component from scratch. So I'm going to give you one possible answer to the fireworks exercise from last week. So to start with, I've got my local loopback scene here. So that's what you'll see when you load it up. And the first thing I need to do is create a new firework. So I'm going to start by creating in this scene here. And I'm going to create a prefab. And my new firework is going to have a cube on it. Let me set that to be 0.2. So I'm going to create like a little Roman candle here. One. So I've got my new firework, and it now exists as a prefab in my assets folder. Now, the next thing I'm going to do is I'm going to add a network game object to it. This is the component that's going to give it a unique identity on the network to allow messages to reach it. So this is not the same thing as the network component, which actually processes the messages. This is more like something that says, I have an identity on the network. The object spawner is going to use this to assign each instance of the firework a unique identity. So now I've created my prefab. I can go into the fireworks box and I can change the prefab that the fireworks box is going to instantiate when I use it, the one that's going to spawn. And you'll see I can now walk over to the fireworks box, use it and receive an error. And this is going to be the first bit that might catch you out. Could not find new firework in catalog. The spawner over here has a list of objects that it's able to spawn, and the reason it has a list of objects is to create references that are known to the Unity editor. So when you build your binary for real and distribute it, it will include all the assets that you might be able to spawn. So Unity by default, when you make a build, won't include assets that are not referenced in one of the scenes which you may load into. So I think the ones that are in the list of scenes in the build settings. So what we're doing here is we're using this catalog, and this is a really nice way. It's underneath, it's a scriptable object if you want to search for that on Google and have a bit of a read about them. It's a really nice way to create direct references and have them persist between design time and runtime. So I can drag and drop assets around at design time, and this same catalog, it can be modified. It's just a list, so you can add and remove items, add items to it and remove them from it at runtime as well. And I can then, in code, use those references that I set up in the editor GUI. So let me show you that, for example, and I get the okay, that's the catalog. That's the catalog there. That's my scriptable object. It's just got a list, but with this list, I can then dereference by index into that to actually get a game object, like the list I'm setting up in the editor using the UI. So it's a nice way to create those associations without using asset bundles, which are a little more complicated. So we won't cover them in this module. So now I've added my firework to my prefabs catalog, and note that this is an asset itself, and this asset is referenced by this and this one. So if you just use the same asset throughout your project, you won't need to worry about updating references for each instance of the network scene amongst the different Unity scenes. Now I create it, now I hit use. And I should, okay. So there is my firework. Where did I spawn it? I think I left the default transform on, didn't I? There we go. There we go. So there is my firework that I can spawn by hitting that. And because it's persistent, if I now join the room here, and I'll join, so I'm going to command this one to join the room, and then I kind of cheat by walking my avatar over this infinite gap, I should see the firework that I spawned before this room joined the game. So that's the first part. That's allowed me to spawn a new type of firework. And as you see, I didn't actually write any code yet. I haven't done anything to other than create a prefab and add it to that list of spawnable objects. So this is not even a network enabled object. I've just spawned a prefab in the scene. But that's not much fun. The firework just kind of sits there. So let's create a script to give it some functionality. Okay, so the first thing I'm going to do is let's make the object graspable so that I can move it around. So I've just added the iGraspable interface. This is one of the bits of functionality that we've written, so you can use this interface from the desktop interface or the VR interface. And all I'm going to do here is I'm going to, when somebody grasped the firework, I'm going to store who's grasped it, or I'm going to store which hand has grasped it, and when they release it, I'm going to set that reference back to null, and then in update, if somebody has grasped it, I'm just going to have the firework box follow that hand. So now I can come here, spawn my firework. Ah, I haven't added a collider to the firework. Oh my, that's excuse me, that's not worked. Have I've messed up the colliders maybe? Nope, I haven't. I put a space in that script. Not allowed to do that. Okay, and now I've changed my, I've kicked off a recompile while the Unity is in play mode, which is going to trigger a horrible bug, which is going to freeze that. So let me just restart that. Okay, pardon me. So got the new firework script. Now let's add my new firework. Now I play. Oops, that's the old firework. Didn't save my prefab list either. And now the firework can be picked up, moved around. I was going to put my firework here. Okay, so now I've created an interactive object, but that's still not very interesting. Let's actually turn it into something more like a Roman candle. So I'm going to go into the prefab here, and I'm going to add to this object particle system. I'm going to turn that around so the particle is facing up. And let's just quickly set this up here. So make this a bit smaller. I'm going to set the simulation space into world space so that when I throw the firework around, the particles appear to follow it. I'm not going to start it on a wake because we're going to want to trigger it manually by clicking on it so we can see that it synchronizes across the two machines. To make that a bit higher. And let's set the radius to 0. And as a final step, let's make those particles fall down. There we go. And finally, the material. So I'm going to use the sparks one I created for the other firework. Okay, so now I've got the particle system on my prefab, I can start adding some functionality to my script. So the first thing I'm going to do is to create the ability to actually activate that particle system at runtime. So I'm going to create a Boolean, and if this Boolean is set, the code is going to check if the particle system is playing, and if it's not, it's going to start it playing. I'm going to get a reference to my particle system. Now, so if I go into my firework, and hit fired, there it sets it off. And in order to allow me to activate it by clicking on it, I can also implement the usable. Face, and this is the one that takes care of the left click. So middle click for grabbing, left click for using. So the next thing I'm going to do is to make the firework a little more interesting. I'm going to have it slowly change the color as the firework is plays. So to do this, I'm going to create a little bit of functionality. It's going to store two colors, and it's going to transition between them, and then when it finishes the transition, it's going to pick another random color and transition to that, so we kind of get this slow rainbow effect. And so let's do that. So this conditional is for while we're doing the transition itself. Sorry, no, this conditional is for when we've exceeded the one part of the transition between one color and the other. So each transition is going to be a second long, and when 1 second has elapsed, we're going to generate another random color to transition to. And while we are between the transitions, we're going to do a linear interpolation between current one and next one. And it's to ignore that, that deprecated warning on this. The particles API is currently changing, but I haven't found new versions of all the ones they've deprecated so far. So that warning is just about that this property is deprecated. And now, when I start my game, I should get a slowly changing rainbow of particles. Now, when I join my scene, when I join the room on both scenes, I will of course get, because we're doing persistent spawning, I will get this object here. And I can also cheat and move across into this second world and click on this, and it's going to start emitting particles itself. However, as you'll see, they are not synchronized because these objects aren't actually talking. I've just created two instances in the same scene that are, for all intents and purposes, completely separate. So if you're on two different processes, these would be doing two completely different things. So the last step is to make these objects network enabled. So to do that, I'm going to implement the iNetwork component interface. And I'm going to register on start my new network enabled component with the network scene, which, as we discussed, is going to be the scene closest to it in the scene graph. Okay, so it's registered. It will now receive messages, although so far we haven't written any code to send a message to an instance of this object, so we're not actually going to receive anything because we're not sent anything. So the next step is to decide who is going to send and who is going to receive. And the way I'm going to do that is very simple. If I spawned the firework locally, I'm going to send messages as to its color, and the other one's going to receive it and vice versa. And I'm going to determine that by another callback which the fireworks box makes. So this interface is just defined up here, right at the top of this source file, that fireworksbox.cs. So all it's concerned with is this particular little example that we wrote for the fireworks box. So it's just one of the part of the samples. It doesn't do anything other than when this particular component spawns an object, it checks if there's a script that implements that interface and it calls attach on it. So that's it. It's very, very simple, very self-contained. It's not going to be done by anything else that we've written outside of this particular example, but it's just a way to get a little callback so that we know whether or not this object spawned it locally or if it's being spawned by a network spawner as a result of another person using the fireworks box. And all I'm going to do here is I'm going to create a new Boolean that's going to store whether I'm the owner of this object. And if that's called, I'm going to set it to true. And so now I'm ready to actually start exchanging some messages. So in update, I can go into use that context object I got when I registered this object to make it enabled, and I can send the color across the network, and then I can pass that here. And obviously this script is going to run, the same script is going to run whether this object was spawned locally by the fireworks box or remotely by the network spawner. So I need to guard that with my flag. So only the one that was spawned by the local user will send colors, and the other ones will receive it. And notice how I don't need to put any guards around this line, because I won't receive messages unless this is true. So if I'm receiving a message, it's because I need to be overriding my local color, because I'm not the primary or the original firework. And of course, because I'm going to be setting the color here, I do need to guard this line so that if I'm the remote version, I'm not overriding my color when I should be receiving it from the network. So now I'm going to go into networks to join the room again. I'm going to instantiate a firework and set off number 1. Now I'm going to go in here and trigger number 2. And if I stand back, you should see that their colors are now in sync. Now, of course, because I'm in local loopback and I can kind of walk between these two scenes, I can, of course, convince myself now that it's done. But in reality, these would be on separate processes. I can't manually walk over and trigger that firework there. So what I need to do now is go back to this firework script, and I need to kind of extend this message. So this function here, send JSON, that takes a type argument, and if I just want to send one type, that's easy enough, one Unity type. But now I need to actually send multiple variables in one message. So what I'm going to do is I'm going to create my own type that I can provide as a generic parameter to this method here. And this will allow me to package up multiple variables, such as a flag to say whether the fireworks lit and a value to say the color, into one message, and then pass that all as one atomic message. Create my new message type. Serializable run, pardon me. There we go. So there's my new type message. Notice that name message is not going to conflict because I've defined this struct within this class. So I'm free to use that type name in multiple places. And I added the system has a type that conflicts with Unity's random type. So I don't want to be doing a using for that. Now I'm going to change the type of message I'm going to be sending to my new one. And here, I'm going to receive that and fan out all its properties to their appropriate local values. Now I can start the game, join the room again. Instantiate the firework and set it off. Okay, and that's it. So that's the simple version, creating a networked object from scratch. So everything you need to create a synchronized object exists entirely within that class, and I can even pick it up and handle it. Although you'll notice that if I do grasp it, we haven't sent the transform yet, so the remote instance is going to stay at its original spawn location, and I will leave adding the transform to that message type as an exercise. Okay, so I will stop there. How do I stop there and leave the rest to questions?
Okay, thanks, Sebastian. Any questions? No. Have there been many tickets? I suppose anybody can see.
Yeah, we've had a few.
Oh, good. All right. So for the rest of the lab practicals, you should just use the ticketing system. If there's a strong desire for any particular sort of more tutorial style work, then obviously you can email me. I might ask Sebastian to do it. But for the last 5 lab practicals that just raise the tickets, you can raise a ticket in the practical itself for immediate response because they're all here. But during the week, if you've got technical support questions, just ask on the ticketing system as well, and somebody will get back to you. We have a milestone in week 7, which is the next lab practicals. There's no practical next week, it's reading week. So 2 weeks from today, there is a milestone for your group coursework, which is I would like you to show one of the TAs what you're planning. The easy way to do that is to raise a ticket in the lab practical next time, spend a few minutes with one of the TAs just describing what you're doing. I know lots of you are talking to them already, but this is just a sort of informal sort of check. I will keep a list, and any group that doesn't show something, I will actually go and chase them, figure out what's going on. Yeah, so for the question that just came up, if it's a specific game with 4 players, that looks all right. Yeah, so that looks fine. It's 4 players, all in different roles. That's fine. As far as I understand, next week is week 6, reading week is 7. I thought reading week is 6 by next week. No, I will go and check. That's what was that used to be. Let me just.
In my calendar, it's entered for next week, but I just pulled it from the UCL page like half a year ago, so it might change.
Reading Week 2021. I found one that definitely says next week is Reading Week.
Actually, if you look at the timetable or the calendars, next week has no classes scheduled.
Good, because I'm in meetings all next week. Yeah. Yeah. I have a lovely week next week. No, I'm in a workshop on VR on Monday. So is Drew. That should be fun, actually. Yeah. Any other questions? Yeah. Okay, so Q&A this week on Wednesday will more be a wrap up. We've had of the talk material from the last 2 weeks. You can, of course, if you've got raised questions about the coursework again, and I'll try and cover them. Tutorial, so the office hour for the module still carries on. So that's tomorrow. And all of those groups that emailed me already about picking up a device at 6:15 today, I have exactly 7 groups have asked, and I have 7 devices. So that's good. I'm afraid if you email me later today, you'll have to wait until I've gone over and checked exactly how many we have. It may be more than 7, but last I counted, it was 7. So don't come. I might go and check now. Actually, that there are actually 7. Unless David Swap tells me there definitely are 6, because I've got 1 here. Is David on? No. All right. Okay. I'll email him now. Yeah. So the last group, I'll just warn you. I'll email you now because I haven't emailed you yet. That let me check that the device is there. Okay. All right. That's it for today then. Thank you very much. Thanks, Sebastian, again. I'll stop the recording and share that with anybody who didn't come. All right.